Hi guys, Dr. Diaz here again, and now we're going to discuss here integration by parts. The integration we discussed last time is by substitution, but sometimes, well, in substitution is pretty neat, but sometimes it has its limitations, and when you have integrals that are a little bit more complicated and substitution does not work, then you have to go to another level or another technique that it might solve these more complicated integrals, and the famous one that is now is integration by parts. So look how it goes here. It says here, using the notation let u be equal to f of x and b equal to g of x. If you have an integral that looks like this, u dv, which is very hard to integrate, this is going to be equal to uv, which is already these elements u of v and v, these terms already integrated, minus the integral of v du, which means you're going to repeat another technique of integration, and it probably could be substitution, probably could be a very easy integral to solve, or probably you have to use another integration by parts because it's actually a very complicated one. To apply this integration by part, you need to make, which this is choice of u and d. So the integral on the right hand side is one that you know how to evaluate. So let's look at an example. Actually, what it means here, what this means is that you have to be careful who you choose as your u and who you choose as your v. And we're going to do an examples of these, and I'm going to do another video doing an example of these integrals that are very complicated. But you have to be very careful. There's a technique that sometimes I heard about that they say it's called ilate or ilate. Let me write it somewhere here. This thing here, ilate or ilate, whatever, which is stand here is for inverse. These are the inverse. These are logarithmic, log expression. These are the algebraic. These are the trigonometric, and these are just the exponential, the e. This is basically the order in which you're going to choose is going to be your u. Okay, so look, call it as ilate, which is stand for, like I said, inverse, logarithmic, algebraic, trigonometric, and e. E is usually going to be the last one, because e to the x, the integral of e to the x is always e to the x, and that's why you see that then the previous one it will be trigonometric, because you know those integrals, sines and cosine, they're well defined. Algebraic is the one who makes it a little bit complicated, because if you choose your v as well, the algebraic one, instead of reducing, you're probably making it bigger. And logarithmic and inverse are very complicated. So let's look at an example. But let's look at an example of how to do the integration by substitution, like we did in last class. Okay, so now you remember this example, right? Let evaluate the integral x cosine of x squared dx. Now here, this one is not that complicated, because the first thing, this one is actually you do it by using integration by substitution, because here the first thing you said is let u, I'm not sure why this thing shows up here, be equal to x squared, and then the u is going to be what, 2x dx, right? And now you have here the x dx. The only thing is that you have a du, and I'm not sure why it's showing all those in lines there, but that's okay. Now if you look here, the integral, right, you use x is going to be x dx. So here you have a 2x dx. Here is your 2x dx, right? Then you substitute du. Well, you have to get rid of that. You take basically the 2 divided here, you will get 1/2 du. That's what they have here, the 1/2 du, right? You can see here. And then the integral of cosine of x dx. Well, now you send, no, actually cosine is called u, and u cosine of x squared is going to be cosine of u, and then you do here just as the integral of cosine of u, the u, which is a simple integral, is going to be sine. Well, in this case 1/2 sine, and then you have, well, it's going to be 1/2 sine of x squared plus c. This integral, we did it last time, and this integral is not difficult, because I mean you said here let u be x squared, the x squared here, and you got du, you got 2x dx, and then the integral turned out to be 1/2 cosine of u du, which is just 1 over 2 sine of u, and sine of u, well, u was called from the beginning x squared, so then you substitute back x squared, you get the integral of this one. Yeah, this one was not difficult, but what if you have something like this? Ooh, here. Doesn't matter who you choose as your u or x, you're not going to get the other part of the integral here. So that means in this case, you have to use another technique. Integration by substitution no longer works. And the integration and the technique here is integration by parts. That's what it says here, integration by part. And the first thing you do is you set let u be equal to x, and the u, I mean in this case, and dv is going to be sine of x dx. Let's see the PowerPoint here. Aha! You see, let u be equal to x, du is equal to the x, dv is equal to sine of x dx, and the integral of sine of x dx is going to be v, which is minus cosine of x. And what you do now, if you go at that rule we saw a moment ago, which is actually here, I mean the rule is here, you're going to substitute here u, you're going to substitute here dv, and then substitute here is equal to uv minus the integral of v du. So who is u? U is x. We have it here. Who is v? V is minus cosine. That's what we get here. Minus x cosine of x. Minus the integral of v. Who we call v? Minus cosine. So minus minus is going to be plus at the end. And who is du? Du is actually dx. So then you have, well, minus minus is going to be plus cosine of x dx. It was the integral of cosine is sine. So the integral of this one, which by substitution would not work, is just by using integration by part, minus s cosine of x plus sine of x plus c. Okay, so what we're going to do, oh well, let's see the other slide before we start solving some of the problems. Look here, poor choice of u and dv. Look if we have done the other way around. So let's look at this same example. Okay, now they choose here u being sine of x, and the u, well, it's going to be the derivative of sine is going to be cosine of the x. And what happened with the v being x, you're going to have what? V is equal to 1/2 x squared because you're integrating both sides. And this is what I was saying. That's why we use elate, right? Remember elate? If you choose, in this case, algebraic trigonometry before the algebraic one, you will have what? Instead of having a simple integral, you have even a more complicated one. Look at the one that result here. This actually is even more harder to solve. That's why if you follow this elate thing, you have to do selection of u, the algebraic one, before you choose the trigonometric one, right? Otherwise, your integral is going to be even more complicated to solve. Right? Okay, guys, I'm going to stop here, and I'm going to do another video in which I'm going to solve a bunch of these integration. This is more like the theory kind of thing. I'm going to solve a bunch of these integration, and check out that one, because that's the one that has the heavy problems, the heavy duty thing on there. And I will show you the technique and explain again how to choose u and dv and how to do this integral, even for things that look simple that are not. Like, look at the next example. This one is not, it looks like a simple integral, but it's very difficult to solve. We're going to do this one in another video. Saying, oh, actually, I can show you here what they did, but I would like to do this one, showing you the selection of u and du and v dv. Okay, and you can check the PowerPoint of this one. Okay, guys, so I see you in the next video.